Welcome you all to the final segment of statistics. So where we will solve the problems given in the exercise 4. So in the first 3 exercises we have solved numerous problems, gone through the concepts related to mean, median and mode. When we talk about group data related to mean, median and mode, right? Now we know that data is represented. We have a distribution table, and given a distribution table, the data can also be represented graphically, right? So in this exercise we shall see how we can represent the cumulative frequency data graphically, right? So there are 3 problems. We shall solve all the 3 of them. They're very simple. So the first problem states that the distribution gives the daily income of 50 workers of a factory. So in the first problem there are 50 workers, and the daily income of these 50 workers of a factory has been given. So the first problem, there are 50 workers and the daily income of these workers has been given. So this is a distribution table here. Okay, so now let us find the cumulative frequency. So the cumulative frequency is 12. So 12 plus 14 gives me 26. 26 plus 8 gives me 34. And then plus 6 is 40 and then 50. Right? Now what does the problem state? Convert this distribution to a less than type cumulative frequency distribution and draw the ogive. Okay? So ogive, usually pronounced as ogive. So I need to represent this in a graphical form. So if you observe, when we talk about data, any distribution, if represented graphically, is very appealing and it gives a lot of information. So if you see a lot of statistics of data, even in news, the temperature, the pressure, the population, etc., etc., it is always given graphically, right? So when the data is represented graphically, it provides a lot of more information. The information is better represented to the ordinary people. So here I need to represent the same thing, this distribution, and convert it into a graph wherein you have the y-axis, which happens to be the cumulative frequency distribution, and the x-axis. The x-axis will be the daily income, wherein we only consider the upper limit. Okay, so this is the income, and we consider the upper limit. Okay, and this happens to be the cumulative frequency distribution. So it talks about the number of workers. Now what is the upper limit? So 12 workers get an income of 100 to 120. So let's assume that it's 120. So there's a break in the graph. So it's 120, 140, 160, 180 and 200. So please remember that these graphs are not to scale. And then we talk about workers, right? So along the y-axis, I have 10, 20, 30, 40 and 50. Right? So in the first case, I have 12 workers getting an income of 120 because I only consider the upper limit, because it's easier for me. So now if I observe here, I have 12 workers. So 12 is somewhere here, getting an income of 120. So this is the first point. Next, I have 140 income, right? And how many workers? So I have 26. So I consider the frequency distribution, right? So 26 is somewhere here, 140. So this means that so next I have the cumulative frequency distribution 26. So this is 26 and this is 140, isn't it? So this difference gives me 14, right? So I have 14 workers getting an extra of 20 rupees when compared to the first 12. So I get the next point here, which is 140 and 26. And next I have 34 maybe somewhere here, and I have 160. And next I have plus 6, which is 40 and 160, and then I have 50 and 200. So somewhere here, right? So I join all of them and this gives the distribution. Okay, so we have converted the entire data into a graph like this. Okay, so this actually tells us the upper limit and as well as the cumulative frequency distribution of the workers here. Okay, so it means I have 12 workers getting a minimum wage of 120, and this difference, that is 14, getting a wage of around 140, and this difference, that is 8, getting a minimum wage of 160, and so on. Okay, so there are different ways of representing the graph. So this is one of the ways which we need to represent. So the second one gives the medical checkup. So there were 35 students, and during a medical checkup they found out the weight of the students, right? So less than 38 there were 0 students, less than 43 students, less than 42 is 5, right? Now less than 42 also includes the students less than 40. So this data becomes the cumulative frequency distribution, right? So less than 52, that means it includes all the students, which is 35. So if I want to know how many students have got less than 38, so what I need to do is, the first one of course is 0, that is to find the frequency less than 40 but greater than 38. So 3 minus 0 is 3, between 40 and 42 is here 5 minus 3 is 2. Next, between 44 and 2, it is 9 minus 5, so I get 4. Next, between 46 and 44, so it is 14 minus 9, which is 5. And then between 48 and 46, it is 28 minus 14 is 14. Next, between 50 and 48, it is 32 minus 28 is 4. And then I have weight between 52 and 50 is 3. So this is the frequency. So I have, say, 4 students in the weight range of 42 to 44 and so on. So this gives the cumulative frequency distribution, right? So now what we need to do, we actually have to draw the ogive. So to draw the ogive, I have the cumulative frequency along the y-axis. Along the x-axis, again I consider the upper limit because that is the way, the standard which is used. So here we begin with 38 and then 40, 42, 44, 46, 48 and 50, right? So this represents the weight, the upper limit. So this is actually the weight, but we are only writing the upper limit. And this happens to be the cumulative frequency of the students here. So I have the distribution along the y-axis. So now 0 students less than 38, so this is 0, so 0, 38. Next I have 3, so 3 and 40 somewhere here. Next I have 5, so 5 and 42 is somewhere here. Next I have 9 and 44, so 9 and 44 will be somewhere here. Alright, so next I have 14 and 46, so 14 is here, right? Less than 15 and 46, I get a value here. Next 28 and 48, right? So 28, so there's a certain increase, so 28 and 48, so I get a value here. And then I have 32, so 32 is a value here, which is 50, and the next one is 52. So 52 and 35. So these are the points I get, right? So now I join these points. So when I join these points, I get a graph like this. Okay? So using this, I basically have to find the median. So we know that to find the median, we usually consider the maximum frequency. So where does the maximum frequency occur? The maximum frequency occurs in this class interval, right? So this is 14. So the maximum frequency occurs in this class interval, right? So therefore, 35 by 2 is 17.5. So to find the median from the graph, what we do is we take n by 2. So when I take n by 2, I get 17.5. That is the mid value, isn't it? So I check in which class interval does the mid value lie. So 17.5 mid value lies in this class interval, that is in the interval 46 to 48. So 17.5 is somewhere here. So I draw a line parallel to the x-axis, and where it intersects this curve, drop a perpendicular, and this would be the median value. Right? So this median value, whatever you get, 46 point something, we have to check it with the theoretical calculations. Now since this is not a graph, I cannot exactly find out the median value. So what you can do is, you can plot this on a graph sheet and then drop a perpendicular onto the x-axis and find out the exact value. And then check it with the theoretical calculation. So let's do the theoretical calculations. So the median class, as we know, is 46 to 48. So L is 46. And what about H? The class size is 2. Alright. So next we also need to find the cumulative frequency. The preceding cumulative frequency CF is 14. And the frequency of the class interval F is 14. Right? So I hope you remember the expression. So the expression for median is nothing but L plus n by 2 minus CF by F into H. So I have L, which is 46, plus 17.5, which is n by 2, minus 14 divided by 14 into 2. So when we do the calculations, we get the value as 46.5. So 46.5 is the median value. So in the third problem, what has been given is production in kgs per hectare, and this is number of farms. So number of farms are there. So what is the production of maybe paddy or wheat, etc. So this is the production in kg per hectare. So we need to change the distribution to more than type, right? So let's see. So if I have more than 50 or 50, so how many farms? So totally there are 100 farms, right? So how many farms produce more than or equal to 50? All of them, isn't it? Okay, so 2 farms produce 50 to 55 kgs per hectare, but all of them at least produce 50 to 55. So the number of farms which produce at least 50 to 55, more than 50 or equal to 50, would be a total of 100. So more than 55 or equal to 55. So what would that be? So we are excluding 50 to 55 from 100. So it's going to be 100 minus 2, which is 98. Next, more than 60 or equal to 60. So we are excluding the remaining 8 from 98. So 98 minus 8 gives me 90. Next, more than 65 or equal to 65. So from 90 I am excluding 12. So I get 78. So what about the next one? More than 70 or equal to 70. So 78 minus 24. So I get 54. Next, more than 75 or at least equal to 75. So I have to do 54 minus 38, wherein I am left with 16. Okay, so more than 75 or equal to 75 would be 16 itself. So I have converted the entire distribution to more than or equal to type. So therefore, again to draw the distribution, so along the x-axis I consider the upper limit. The upper limit of the production. So I have 50, 55, then 60, 65, 70, and then 75. So here we find the cumulative frequency distribution, right? So this is 100, and then 90, and then 80, 70, 60, then 50, 40, 30, 20, 10, and so on. Okay, so at least 50 here. Okay, so since 50 happens to be the benchmark, so I consider 50, 55, 60, 65, 70, and 75. Right? So how many farms produce at least 50? It is 100. So it is 50, 100. How many farms at least produce 55? It is going to be 98. So it's going to be 55 and then 98, another point here. Right? Next, how many farms produce at least 60? So it's going to be 90. So I have 90 and 60. How many farms produce at least 65? So it's going to be 78. So 78 will be somewhere here. Now how many farms produce at least 70 is going to be 54. So you have 54. And how many farms at least produce 75? So it's going to be 16. So we see that when you join all the points, I get a graph like this. So you join the points here. Right? So this is what, so this indicates the number of farms, isn't it? So the number of farms having 75 and more is going to be 16 and so on. So this is how we interpret the graph. So we finally come to the end of statistics. It's a very interesting and a very important topic today because data analytics, we get a lot of information from data, and the whole idea is, can we get more and more information from data so that we can make conclusions, right? So statistics happens to be a very, very important topic. Right? So make sure that you go through all the other lecture videos in statistics which have already been uploaded, and also go through all the other lectures in other topics like trigonometry, probability, arithmetic progressions, circles, and most of them have been uploaded. You can check all the videos in the playlist CBSE NCERT 10th Maths. The link has been given in the description. Make sure that you watch all of them, practice all the problems, and I'm sure you'll really do well in your examination. Thanks for watching. Do like, share and subscribe, and do not forget to press the bell icon to get notifications of further uploads.